All right, let's try this advanced level practice. Thanks to Beatrice, who posted it in our GED Facebook group. Now, just to be clear, this is actually challenge level. There's a reason why it's an advanced level practice. It's beyond the level of the GED. However, it takes two GED concepts, distribution and perimeter of rectangles, and extends them even beyond what we see on the GED in order to prepare you for college, which is just what Beatrice is doing, preparing for college. So let's take a look. Directions say find the simplified area of the rectangle. Now, before you let yourself get freaked out by what we see here on the measurements of that rectangle, the width and the length, that's what's freaking most students out. Before you look at that, just remember this. We know this from the GED. Even the most beginners of us learned about finding the area of a rectangle in the fourth lesson of algebra, right? We start talking about using the formula sheet. So we could hit up the formula sheet. We see area of a shape, we can hit up the formula sheet. And you'll quickly see that area of the rectangle is on the formula sheet. It tells us something in the language of algebra. It says to find the area of the rectangle, that's going to be equal to, that's how we find it, the length, L, shoved up against W, meaning that they're multiplying. So to find the area of a rectangle, multiply together the length and the width. Now, it doesn't matter if it's simple little numbers like 5 and 4, or if it's ugly little numbers, big numbers, ugly algebraic expressions, like 2p and 3p plus 11. The way we do this problem is going to be the same. It's going to be according to what our formula shortcut tells us. Multiply the length and the width. Now, you might say, which one of these is the length and which one of them is the width? Really doesn't matter. They're interchangeable on a rectangle. But I think I'll start with the simpler one, just because you guys usually make less mistakes when I do. So what I'm going to do now is I'm going to replace length with this expression 2p. You say, Kate, aren't I supposed to get rid of the letter when I do substitution? Well, yes, when I know what number it's equal to. Like if I knew the length was 2 inches, I would just put 2. But I don't know it's 2 inches. I know it's 2p, some unknown number p. And so I'm just going to put in 2p. And then same thing for w. W is not just a number in this case. It's a whole long algebraic expression. Well, that's cool. I can plug that in. 3p plus 11. But I want you to be careful, just like we always have been, to remember that we need some kind of a symbol to say that this length and this width are multiplying together. Just like we did when we put numbers in, we said if we leave it like that, it's going to look like 75. We need to make sure we have some symbol to say multiplication. We're going to need to do the same thing here. Please make sure that the second expression, the entire thing, 3p plus 11, is in parentheses. And that's what makes this a distribution example, because this 2p is multiplying with this entire 3p plus 11, or looking at it here, this 2p is multiplying with the whole grouping with more than one term. We need to pass it out. And so now then we see another GED skill come up, the skill of distribution, passing out multiplication to every term, everything adding and subtracting in the grouping. So let's do that. Let's start with 2p times 3p. Oh, look, there's another GED skill. Okay, now it's 3. All right. We talked about multiplying algebraic expressions in algebra as well. Remember that we can multiply together the numbers, the coefficients, those numbers out front. So 2 times 3 is 6. And then you might say, but Kate, I cannot multiply p and p. I don't know what p is. No. So you're just going to shove it there. But careful, don't forget, I have 1p and then another p multiplying. I have 2 factors of p here. Just 2 p's multiplying. That's all factors mean. And we had to use something to talk about repeated factors. What did we use to talk about repeated factors? Exponents. And so that's not just going to be 6p, that's going to be 6p squared, which literally means 6 times p times p. Awesome. So I pass that 2p out to the 3p, but I have to pass it out to every term in the parentheses. So now I need to multiply the 2p times the positive 11. So 2 times positive 11 positive 11 is positive 22, and this time there's just a single solitary p multiplying, and so I'll see that in my answer. And now, a lot of students want to keep going here, but remember, oh look, another GED concept, combining like terms. So a lot of students want to keep going here by adding this, but we cannot add. Why? These are not like terms. We know we can only add and subtract the same kinds of things, which means we're not going to be able to add p squareds with p's, and so we're literally done. I know it looks gross, but with the mystery of p being what it is, this is as much as I can do for this problem. All I can say is whatever the area is, it's 6p squared plus 22p square units. And honestly, probably nobody's going to test you on the square unit thing, but you know how anal retentive I am that you guys know that when it is area is measured in square units. It's the number of squares to cover a shape. All right, and you're done. All right, I know, looks gross, but remember, one of the most important things in algebra is to know when you're done and it's time to go home and sip your tea. All right, Beatrice, thanks for putting up this problem. I'm excited to do it. People always ask about it, and I always say, it's in the advanced level practice, don't bother. But today, I already spent enough time making myself mad on Facebook, so nice distraction. Appreciate you guys. Happy learning.